Hello and welcome to episode 110 of the Machine Ethics Podcast. This time we're talking with Ewelina Kurtys. This episode was recorded on the 22nd of January 2026. Ewelina and I talk about the uses of organoids and the unknowns of neuroscience, difference between biological neurons and digital neural networks, encoding information and working with dynamic systems, the impracticality of creating brain structures in the lab, biocomputing, energy-saving computing, and we go on to talk about determinism and much, much more. This time we're again sponsored by Area. AI innovation shouldn't compromise ethics or security. Meet Area, the AI platform that empowers everyone on your team, from non-coder beginners to pro developers, to innovate responsibly. With enterprise-grade security, cost controls, and a prototyping studio for rapid, safe experimentation, Area ensures you can build smarter AI while managing risks, safeguarding data, and staying compliant. Transform chaos into streamlined AI control. Future-proof your business, unleash innovation. Future-proof your business, unleash innovation, and embrace AI responsibly with Area. Learn more at area.com. That's AIRIA.com. If you like this episode, you can find more at machine-ethics.net. You can contact us, hello@machine-ethics.net. You can follow us on Blue Sky, machine-ethics.net, Instagram, Machine Ethics Podcast, YouTube at machine-ethics. And if you can support us on Patreon, patreon.com/machine-ethics. Thank you so much, and I hope you enjoy. Hi, Ewelina. How are you doing? Who are you, and what do you do?
So I'm Ewelina Kurtys. I'm a neuroscientist by background. I'm a scientist, but I left academia for entrepreneurship, and I started to work with startups. And I switched to artificial intelligence, as this is very fascinating topic, which is also inspired by neuroscience. So I feel a connection with my previous field. And currently I'm working as a strategic advisor for Final Spark. This is a startup in Switzerland, and we have a dream. We are building computers from living neurons. So the same neurons as we have in our brain, but we have them in the lab on the dish, and we want to use them as a processor. Instead of silicon processor, we want to use living neurons. That's what we're trying to build at Final Spark.
So I feel like if you're listening to this on the podcast, you've probably got a load of questions already at home. So I'm going to try and, go through some of the questions I have, and then it might be one of those things that you could always just get hold of me or Ewelina afterwards if you have some more questions. But we'll get to that at the end. So what I wanted to start with was you were talking about this idea of we can explore the neuroscience connection, definitely. But there's this idea that we have a living computer, but as we usually start with some definitions. So what is a computer? How can we take that computer-ness and then put it into wetware or bio stuff?
So biocomputer. So currently we have prototype. We culture living neurons in the lab, and we have a little blob of cells, which consist of around 10,000 neurons each, and they have around 0.5 millimeter diameter, and we create them in the lab, which is actually normal procedure. These structures are called organoids of living neurons, and they are widely used in biomedical research. But we use them for different purpose because we want to build a computer. And what we do, we put them on electrodes so that we can send them electrical signals, and we can also measure the response. This is also nothing new because many people do this for studying neurons, but again, we do this for different purpose because we want to build a computer. So basically, we send electrical impulses to neurons, which is input of like in the computer, and then we also measure the activity of neurons, which is output, like in the computer also. And we want to achieve meaningful relationship between input and output, like in the computers. But of course, the hardware is totally different than silicon. And there are different rules for encoding information or processing. And this makes the whole project very difficult because we have to learn how to communicate with living neurons, and we have to rediscover completely new approaches.
Yeah. And I think because in my head, computers are like traditionally silicon, like you pointed out, or comprised of doped silicon chips, which encode transistors in a formation, right? I'm getting there. That enables us to do arithmetic and put pictures on screen, to do all sorts of jobs, right, in a computer that we want to then interact with, like you were saying. So do some input, the computer does some processing, does some arithmetic, does some stuff, and then produces the outcome, which might be changing pixels, might be playing some audio. So what's the difference? Kind of, is there a job specifically that the neurons are going to be good for? And is that analogy not correct, right, with the traditional computer, because you have these things which aren't transistors essentially?
So yes, so living neurons are totally different, because transistors have this 0 and 1 system, yes or no, and the neurons are very, very complex biological system, and they produce spikes. So they produce impulses of electrical impulses, and the information is encoded in time and space, so it matters where in your brain. Or in the organoid in the lab, so it matters the location of the neuron and also the time when it was active. So this is how the information is processed. So all these fundamentals are totally different. It's like with quantum computing. Quantum is also totally different than silicon. So also the whole idea of how this computer will work will be different. But when it comes to the tasks, we can have some ideas what neurons can do well, based on how human brain is working. And we know that human brain is extremely efficient in analyzing complex information and with very low energy. And we believe that generative AI will be a good use case for living neurons, based on how we see human brains, because it will be able to generate ideas, solve some very complex problems, and with much less energy. So generative AI is a use case, we believe.
Yeah. And do you see that? Is it sort of the thing that you'll be able to, like you were alluding to earlier, that it's quite difficult to encode that program essentially into the cells? So how does that work at the moment, or how is that going to work?
What do you mean, encoding?
So if you want the system to encode information about an image, let's say, how would we? So ordinarily in a computer, you'd program the computer to do some action using the stuff on the chips that you have available. And I'm just trying to work this through my brain here. Okay. So in the lab, you have a set of things that the neurons can do, and that you build those things up and you program that somehow to do those in combination? Or is it more like the neural network style thing where you're not really programming it, you're brute forcing it to take one input and produce an output over and over and over again, and it's going to learn some sort of function in between?
So I guess it's the second one, because also neurons are like a black box, but real one, because we cannot really measure the connections between neurons. It is too complex, and there are also no methods to keep them alive and check the connections.
Are they quite sparsely or quite well connected? The neurons?
Very well connected.
Yeah. Okay.
Very well connected. A lot of recurrent connections, which are also existent in the silicon, but much more difficult. And so I would say that we try different things. We try to stimulate neurons and make them do something. So it's rather a trial and error, I would say. Maybe not a brute force, I don't know, maybe trial and error, because you just have to try million of options until you have something. And the problem is, what is the biggest bottleneck today? Is that nobody knows how neurons encode information. That also is a big question for neuroscience, because answering this question can also accelerate some stuff in the neuroscience field, in medicine. But nobody really knows. We know a lot about spiking, how they process information, but we do not know what does it mean, how it's encoding information. So that's a big secret. And that's also why we have to do so many trial and errors, because we don't know really what we are doing. So we are doing a lot of blind trials to see what is working.
Yeah.
That's why AI and automation is very helpful, by the way, because here you have to do huge amount of experiments.
Yeah. So you can use those tools to in the lab, and do experiments in the lab. That's awesome. So for me, naively, I'm not a neuroscientist, but my understanding, right, is that you have neurons which have this analogy with neural networks, which are in machine learning, and we could talk about and AI stuff, the AI area, but they don't work the same, right? So I want to just get that out to our listeners. They're not the same. They don't work that way. So my understanding is that the biological neurons, they are connected to each other. They have this electrical pulse, but which they are able to pass on, and there's a connection between them, which enables that passing on of that electrical signal. But there's also the chemical in between, the kind of that inhibits or exhibits that passing on of that electrical signal as well. Is that true? And is there anything else going on that we haven't covered?
Well, it's true that neurons are producing electrical signals, and this is how they encode information. We just don't know how to translate this, so we don't know exactly how they are encoding, but that's for sure. They also communicating with chemical signals that we also use in the lab. So, for example, with neurotransmitters, so we are able to release dopamine in the medium, which hopefully can help learning. So
in your tests, are you doing both of those things? So you're sending different chemicals and you're sending electrical signals.
Yes.
Yeah. And have you had this might be telling, all right, or something that you might not want to discuss, but have you had many successes yet in being able to kind of like do useful computation, essentially?
We managed to store 1 bit of information so far. That's something we've done reliably, and many times we were able to reproduce the results. So yeah, that's our little success. So this also illustrates how early stage it is at the moment. We are very early in the development of biocomputer.
And how many neurons did it take to encode that?
Oh, well, this is more like on the global. So we have this little structure, organoid, which is built from 10,000 neurons. And we were able to change the state of this organoid. It's more as a whole, but it doesn't mean that only one bit can be stored in the organoid, but it's just that this experiment was designed in such a way that we just changed the state of the whole structure.
Yeah. And I guess it's in, because obviously it's growing almost into a new state. Is that the right way? How do you talk about that? Living,
yes,
let's
that's
say.
True.
Yeah. Yeah. So it's kind of changing its state by, I want to say growing, but continuing to live, but in a different way.
Yes, absolutely. You're right. Because neurons, in contrary to computers, are a dynamic system, not stable. So they are changing all the time. And this is normal. Also, our brains, which are built from neurons, are changing through the interactions with the environment. So this is just biology. And this also makes more difficult the reproducibility of experiments, yes, because we have to learn how to work with this dynamic system. But for sure it's possible, because our brains, despite being plastic and dynamic, they still can do consistent repetitive work. So it's possible, we just have to figure out how.
Yeah. I mean, if you talk about it like that, it's almost like, how do we have this continuous existence? Is actually amazing that we can even do that at all. Like this, from moment to moment cognition that is stable in a way that we understand it as, a continuation of ourselves is quite amazing. How do you make these organoids? Are they like a specific kind of representational structure from the brain, or is it a new structure, or is it what is
no
that?
It's completely random. We are using cortical organoids, so the neurons are similar to the cortex of the human brain, but they form connections spontaneously. It's just biological process. When you put neurons together close to each other, they will form connections naturally. and it's totally random, and it doesn't really represent some specific region in the brain. I think this is very difficult. What you can do in the lab is to have some specific cell type, but you cannot really make the structures. I think it's impossible. That's why we can never build brain in the dish, like many people say, which I think is mistake. There is no such a thing like brain in the dish, because what we have in vitro on the dish is totally different. It's not the same structure as in the brain. Brain has a lot of fine structures which are formed by evolution, billion of years. So we cannot really do this in the lab. So we usually use just the cell type, which is characteristic for some region. Yes, that's what we can.
But so you couldn't make up the regions of the brain in the same way, but you could put one organoid next to another organoid and kind of get them to start communicating.
Yes, absolutely. People try to do this, but it will never have the same structure like in the brain, because in the brain, the way how the neurons are organized is very fine and very specific, and I don't believe we will ever be able to reproduce this in the lab.
No, that's really interesting.
Although you can combine, sorry, I interrupt you. You can absolutely combine different cell types. That's what people do. And these are actually these organoids, which is now hot field in neuroscience, very powerful for research, but still, I think it has nothing to do with the brain. It's just the same building blocks. Yes.
Yes, yeah. So it's an abstraction, but using the same kind of stuff, isn't it? So what is it? I think you might have touched on it a bit at the beginning, but like, what's the vision for the company, and is it something that you're excited about personally?
So we want to build a biocomputer. This will be biological computer, centrally available, huge bioserver with living neurons, and you will be able to connect to this like today you connect to the cloud computing. And what will be the difference for the end user? Actually, we want to have no difference in terms of interface. Because just hardware will be different. Like today also you can change different hardware, but still computer looks the same. But what we want is that it will be much cheaper, because we don't feel it yet, because of course ChatGPT, for example, or other LLMs, which I'm using a lot for my work and also some private stuff a lot, it's still very cheap compared to the cost, because OpenAI is losing a lot of money, like they lost 19 billion US dollars. And that's normal, because every big tech company at the beginning is losing a lot of money, and they sell the product very cheap to ensure adoption, and that people learn how to use it and they get used to this. It's normal. But in the future, these prices, if they want to be profitable, they have to increase the price a lot. So actually, we don't realize this, but AI is very expensive. So what we want to do, we want to solve this problem and provide the hardware so that we can run AI much, much cheaper. So that's what we want to achieve. More accessible artificial intelligence.
And is it the case that you would have like a model that would then run on the neural?
Well, this is hard to say, because when you look at the history of silicon, you see that different companies build the hardware and different companies build the software. And for me, it's hard to predict the future. For now, we focus on building hardware. And who will build the software is a question for the future.
Okay, cool. But it might be also you, right? Yes, yeah, exactly. So it's funny. In my mind, I go to a very sci-fi space, right? Yes. So a lot of people in AI and things at the moment, there's lots of talk about AGI, and there's lots of talk about the personification of things, and how giving these things rights, or giving these things, or being worried about these things because they are some sort of being, whatever. There's lots of like things which you may or may not subscribe to. But if you're, it's funny, because if you run, let's say, if you are getting a organoid to learn about text and images and things, and then it's slowly learning about stuff, and you're slowly making something which is akin to what ChatGPT is, let's say, but it's also got this component where it's the hardware is kind of wetware, it's getting to that uncanny valley very quickly about how people feel about a machine being more like us, right? And the questions about having this thing which maybe exhibits some intelligence. Then let's say it's just a tool, but it's also a brain essentially. So it's got like this other thing which adds credence to this idea for people. Is that something that you're kind of grappling with, that you're essentially making tools out of bits of organ which could become beings essentially? Again, this is very sci-fi, but it's high in people's minds, right?
Yeah, I think this is philosophical problem. I personally don't believe in that. I think it's our bias. We think we see living neurons and we think, oh, they are humans. And there is a lot of stuff like that on social media, that we are enslaving brains in the lab and stuff like that. I think this is not really correct. And I don't think this will be beings. I think maybe when the AI will be more intelligent, we always have this question, and it doesn't matter if it's silicon or other hardware. If AI will be more intelligent than us, then we have questions whether it's actually like us or maybe it's still machine. But I personally don't really believe in this. I think people are using too much anthropomorphizing. Also, neuroscience research, way too much. They unnecessarily say that you have brain in the dish, which is totally not true, because it's not a brain, it's just living neurons, and it's not the same as the brain. And I think this creates a wrong impression of the public. And I hope this misunderstanding will be solved by philosophers, because we actually try to promote this topic among philosophers, and we hope, of course, we never pay them, so they are free to say, maybe they will say something else than me. So absolutely, sure. They are free to say what they believe, but we hope that soon we can have some reference from the real philosophers about these ethical questions. Because they are very interesting, of course, and every new technology is, I think, bringing new questions which we haven't had before, and it's very important to address them and make sure that our technology is good for the better, not for the worst of the society.
Yeah, well, feel free to send any information to me about the philosophy side. I'll be interested to learn more, and
I think now I don't
have an opinion.
Official update which I can disclose, but I think for anyone, including you, but anyone who listens, who is interested, the best way is to subscribe to our newsletter. You can do this on our website, finalspark.com, because once any philosopher publishes something about biocomputer, I'm sure we will add this to the newsletter. And we send this only every 6 months, so it's not a lot, but I think this is... sure, we will include this in the newsletter. Yeah.
Great. And is there anyone else doing anything akin to what Final Spark's doing currently, or is it a big market, or is this the frontier of this new way of doing computing?
It's definitely frontier, and we are creating new industry, but we have competitors, and we are actually happy with this, because we hope that means that our work makes sense, because if we wouldn't have competitors, maybe we would start to think maybe it's too crazy, maybe it doesn't make sense. So yes, luckily we do have competitors, and the biggest competitor is Cortical Labs in Australia. And to our knowledge, there is also another competitor, Koniku, in the US. And we are in Switzerland, Final Spark. So that's, to the best of our knowledge, that's it. For the serious players, let's say, in biocomputing, because a lot of people, of course, work on organoids, but for different purpose.
Yeah, and I guess some of that research can be incorporated. I mean, what excites you? Because obviously you've done a lot in your career in science, and I saw you were making apps, and you're interested in AI and all this sort of stuff. So what is the thing that's really exciting you at the moment with this kind of area? Is it the chance to work on this frontier thing, or do you have this other kind of passion going on?
So I like to do things which nobody else is doing. that's why I become a scientist, because when you do research, usually your project is quite unique, and it's hard to compare you with others. And I never like to be like, compared to others. I like to do something different always. So that's why in startups, I like a lot this deep tech projects, because they are very unique. And this is really great, because it's like, I don't know anyone who is doing a job like me, and I like it. So of course I have colleagues, but each of us is doing something different a little bit at Finance Park. So that's what excites me, and what excites me is also exploration. Always, I love to explore, and still, like a scientist, I like to experiment, because when you do something new, nobody else did before, you have to experiment. Sometimes things don't work. You have to figure out, and anything, not only R&D but also commercial side, because I'm mostly working on commercial side. This is still to be explored, because it's new industry. You have to figure out who is the client, how to push things forward, and I love that it's not that I have to figure out. It's not that someone gives me a recipe, and that's what excites me, and just the way of working. And I think that's for me more important. And the culture, of course, is nice, because the team is really nice, and I think it's always like that with the deep tech projects. People are usually super nice, because they are focused a lot on their own work. So there is not so much space for politics or other stuff, because people are very focused on technical stuff, which I like. And then I think it's easy to work with such people. That's what I enjoy a lot. And also, small organization is always easy, because you have everything on the palm of your hand. It's easy. You can see everything. I think if I would work in the big organization, I would feel a little bit confused that I don't know everything, and I like to know everything. I like to have bigger picture, and with the startup is easier. It's easier to grasp the whole picture than I think in the big organization becomes very complex. So yeah, that excites me, the way of working on such a exploratory new projects. This is nice. This is very, very cool. And I'm happy that people have money and time to work on such crazy stuff.
Yeah. I mean, when you contacted me, I was kind of like, I had an inkling that this type of work might be going on, but to actually then to discuss it and talk about the pros and cons of it is just like, wow, like this is really cool. This is happening. This may be very, very useful. That's the plan, isn't it? Is it? This is kind of a very big tangent, but because because these things are like living organisms, do you get upset? Not upset, but do you feel bad turning it off, that sort of thing, or?
I wouldn't call this organism. Again, we go to anthropomorphization, which is absolutely normal. I think it's normal thing. I don't see this as beings or organism. These are just cells. So it's the same like you scratch your skin, Every time, your skin is producing new cells, and the old are dying. And you can even do some treatment aesthetic to help to remove this dead skin. So it's like you would feel sorry for that, would you? And actually, as a biologist, I can tell you, that the cells in our body are exchanging all the time. So actually, on the philosophical level, we are not built of the same molecules as we were 10 years ago, because everything is exchanging. So I see this as a nature, and if cells are dying, I don't feel sorry for that. Maybe, yes, some people criticize me, but I really hope that we get some philosophy papers to support that statement.
What are the critics that the opposite of that, or do they have a strong argument because it's brain material, or because it's what do you know what their arguments are?
What do you mean?
The people who are against what you're doing, essentially.
No, I don't think so. I think it's mostly based on feelings, because social media works that way a lot, that our attention is grabbed by feelings of shock, outrage, whatever. So I think it's mostly feeling based. I never heard solid arguments against working on biocomputer, which would be like a reasoning. No, I don't think. I think it's feeling, but it's also fair. It's really fair, because not everyone is an expert in biology, and it's normal that for people who don't work on biology, I've been in the lab for 15 years, so I've seen, I get used to this, but it's normal that someone doesn't, and now they hear about living neurons in the lab. Oh, what does it mean? And it's normal that people are surprised. So that's why we need philosophers to guide us.
Yeah.
Because maybe if a scientist says it's normal, you don't believe, because, okay, I have interest to continue the work. So that's why we hope that philosophers, independent, not paid by us, hopefully they will support this. But yes, I think it's normal feeling, that for some it's outside.
I've come up with a argument,
Yes.
all right? Just listening to you. So, okay, so I taking into account everything you've said as a given, right? Let's start from that position. Would it be the research you're doing could be then applied to a living brain?
Oh yes, absolutely. But it's not our objective. But yes, it is.
Yeah. So there might be a consideration where we can use some of these techniques and some of these abilities with not just this kind of tissue, let's say the living tissue that the organoids and stuff that you're creating, but also on other living tissue elsewhere that may be whole.
Absolutely. Yes, it's possible. And actually we hope for that.
Whatever.
Because every time you work on deep tech, you have this kind of side effects. Like results of your work can be used in other applications, which is not an objective, but someone else can use them. Yes.
Yes. And is there not a worrying aspect to that?
I think if it's technically possible, it will happen anyway. And it's like with technology. With every technology, you can see good and bad. Because we can see you might think that, oh yeah, we can manipulate maybe human brain is very dangerous. That's one side. But other side is what if we can cure disease after stroke, for example, or other disease where you have brain damage? Maybe we can reproduce this damaged part of the brain, and maybe it can go even further, not only to cure disease, but maybe we can enhance the brain. For example, maybe one day you can upload foreign language into your head and you will speak Chinese fluently in a week. Who knows? Wouldn't it be that cool?
Yeah.
So I think every technology has good and bad, but if it's technically feasible, then sooner or later someone will do this, because it's not like I think discoveries are following. We are in some constraint area. And it's not like we make discovery the only one who can do this. If we don't do this, then someone else will do. Someone else will do this if the state of the art is ready for that. So I think it's just if something is possible, it will happen anyway. So there is no way to stop. I think, and the only thing we can do is to make sure that we use this for good, not for bad. But we can never stop technology. I think it's always possible to use it for good or for bad. So but I agree with you. You can also be bad. Yes.
Yes. Yeah. So so what you're saying is that any technology can be used for good and bad, and
absolutely the knife, even the knife, it's a very trivial example. You can cut the bread or you can kill the person, and everything else. Also, artificial intelligence. We have a lot of. I was reading recently Time magazine. They had a special edition about artificial intelligence and different cases about how AI affects our life. And from one side, you have people, they use it for work. Me too. It enhances my work incredibly. It increases my productivity. But on the other hand, you have cases then that someone, for example, committed suicide after talking to ChatGPT, or there are some other problems sometimes. So, like with every technology, it can be good or bad, and actually, we of course have to be careful. I don't say we shouldn't, but I think absolutely every technology has two sides, good and bad.
Yeah, it's. I think for me, it's like there's this trap of like techno-determinism that if we can do it, it will happen.
Yes.
But there's a subtlety there, right? That we don't have to do it.
Yes. But I'm sure that if we don't do this, then someone else will become more advanced. I really believe that this determinism you said, I really believe that, because there is now a lot of competition between like US and China maybe, and Europe is actually not a big player here now because we are a bit behind. But I really believe so, that if something is possible and people want this, then they will get it. You don't think so? It's not. You don't agree with this?
No, I don't agree. I think I think you see it all around you. I think the pitfalls of the deterministic view is it makes it absolves you of responsibility, right? So if I don't do it, someone else will do it. It's an arms race, blah blah blah. So you get down to that issue. But if you think about history, right, it went in one direction and not in another direction. So if you, I believe deeply that back in the early 19th century, we had a choice to make silicon and or do something else, right? And we chose to go down transistors and silicon, stuff like that. We could have spent more time doing biological systems and doing wetware.
I think it was too early for that.
That may be, but I think if we actually focused on that, I think we would have a very different situation right now. And again, like this comes up again and again, but we also decided not to do so much GM, right? Genetically modified foods and stuff like that. So some things we didn't do and some things we can do, but we choose not to do. So I think the whole techno-determinist viewpoint is not valid for various reasons, and for those reasons specifically for me, it seems obviously invalid, because you don't want to absolve yourself of doing terrible things, basically. But not to say that what you're doing is terrible. That's not what I'm saying. I just don't like that viewpoint.
It's actually interesting what you said, but I think you talk about Europe here because we decide not to do something. I think also the cloning. I think something was about the cloning. Like after they did the dolly, they stopped. But again, this will not happen maybe in Europe, but maybe somewhere else. Yes, and for example, if you talk about genetically modified organism, that's what you talk about, yes? I think in Europe there is a lot of hype about not using them, but on the other part of the world, they are used. Because also at the end, unfortunately, I think money decides. And for example, if you have, I don't know, strong financial reason to use GMO, the people will use it. And I think still it is used on other part of the world much more than here. And still in Europe, we have also GMO. I don't think we are clean of that. And actually, I'm not against that because I studied biotechnology, but that's another podcast. But I'm just saying that I believe that we can, that in some restrained area like Europe, you can decide not to do something, but that doesn't mean it will not be done somewhere else. And I think also that, you know, that we don't really decide about, it's not that we choose the progress in which direction, because you said we could choose between silicon and wetware. I actually would say that it's not that we have choice, because the technology is ready. For example, like 50 years ago, we were ready to work on silicon, but we were not absolutely ready to work on wetware. And I think sometimes the progress follow what is possible. So, for example, when people did iPhones, yes, it's not that they had a choice, but it's kind of become possible, because before the technology was not advanced enough. For example, why we can do wetware? I tell you, since 15 years, we can produce, there was a Nobel Prize for that by a Japanese researcher, we can produce neurons from stem cells from human skin. So we don't have to sacrifice anyone. Before, it was very difficult to get neurons. So, for example, that's one of the reasons why it was be very difficult before to do this research. Another reason is also the development of artificial intelligence, because actually to do the wetware computing, we need a lot of silicon AI. And it would be very difficult to do this without. I mean, there are some pioneering works like from 20 years ago, but they are very few. But I think...
when you say biological, silicon AI, do you mean machine learning techniques, or do you mean
any kind of, including new LLMs, ChatGPT, everything? Artificial, yes, because you know this can be used to accelerate the work, and because the problem is so difficult, I think it may make a difference. We also use a lot of automation in our lab, and we use, for example, ChatGPT to write the script in Python programming language and to design the experiments, so we can run everything faster. So. Yeah, I think that the progress is not so much by choice, but it's more by what is feasible. But it's just a very interesting exchange, you know?
Yeah. I think what you're saying. I'm going to put words in your mouth here. I think what you're saying is that the universe is deterministic, and I'm saying that it's not.
Yes,
And that's
definitely. And it's ongoing discussion also in biology about whether stuff are deterministic. Yeah, I believe in determinism, definitely. But it's really belief. Here we are outside science, definitely. So
it is one of those big conversations, isn't it? Yeah.
And also
definitely.
still, I'm not a real philosopher, like philosopher who is writing books on philosophy. So I think those people have a better view, and I'm sure there are still philosophers on both sides for deterministic and free choice. Yes. So.
Yeah. I think it's one of those things where like physicists have a big thing to say about it. Philosophers have a big thing to say about it, and everyone else is like, I don't know, maybe. Who knows? Does it matter? Probably not. So yeah. So is there anything else you wanted to talk about before we ask the last question?
No, I just wanted to mention that everyone who is interested by our conversation, I highly encourage to check our website finalspark.com. And there are a lot of information. We have Discord community for technical discussions. We have also newsletter, as I mentioned before. You can also send us a message. We have different forms on the website, and we answer every message. So if anyone has any kind of questions, ethics, marketing, or technical, we are happy to discuss everything. Also investments, yes, because we are talking to investors currently. So we are currently self-funded by the founders because they have already another company in digital, which is profitable, so they can fund Final Spark. But we have limited resources, and we are talking also to external investors. So if anyone is interested, we also encourage to get in touch.
Brilliant. So the final question is, what excites you, or what scares you about our AI-mediated future?
Excites me the possibilities, because I'm really I cannot believe how much ChatGPT can already do. I use it for many things, personal and work, and that excites me. But on the other hand, it also scares me, because if AI is so good, maybe one day we will become obsolete. And I personally am not so much afraid, because I think if you know how to use AI, you will be always in the good position. But I'm a little bit concerned about the future, if maybe we have like 10 or 20% of unemployment. I don't know if this is possible, because maybe I hope really that new jobs will be created. After AI will replace existing job, I hope we will have new jobs, like always happens with technology. And I really hope also this will happen now. It's just our imagination maybe is too short, because also like 30 years ago we couldn't imagine that there will be job like search engine optimization manager. So it's normal, it's hard to predict. So but this is a little bit scary because it's unsure, but I generally look positive on the future, and I'm sure it will be great.
Great. Well, that's a very positive sentiment to end on. So thank you very much for your time and speaking with us, and I'll speak to you soon.
Thank you so much.
Hello and welcome to the end of the episode. Thanks again to Ewelina for coming on. Completely fascinating area of research and science that I had barely touched and knew anything about. So it was really great to dive into some of those intricacies of the kind of wetware nature of what computing could have been or could be in the future, and the different worries and issues and things that are associated with that. So I found this episode really fascinating. Obviously, there's a continued kind of discussion around determinism. I feel like that one comes back again and again in these episodes. Always great to find out what you think. If you want to contact us, hello@machine-ethics.net. And if you can support us on Patreon, patreon.com/machine-ethics. And as always, you can rate us on wherever you get your podcasts and share the gift of the podcast to a friend. Thank you so much for listening, and I'll speak to you next time.